Welcome, Calculus BC. This is lesson 8-4 ratio test. Let's begin. So, ratio test is going to be our last test of convergence or divergence. And here it is, your ratio test. So, usually we use this when we're involving factorials or exponentials. And so, if your sum converges, if the limit of a sub n plus 1 divided by a sub n is less than 1, or the absolute value of that is less than 1, and it diverges if it's greater than 1 or if it's going to infinity, and the test is inconclusive if the limit equals 1. So if it's kind of that fraction, kind of like geometric series between -1 and 1, it converges, diverges if it's outside of that, and it's inconclusive at 1. So this is really good, again, for factorials or exponentials. If you had polynomials, those comparison tests were better. And instead of thinking about this as a sub n plus 1 over a sub n, think of it as a sub n plus 1 like times the reciprocal of a sub n instead of dividing. And when I say n plus 1, this is like the formula for a sub n, and n plus 1 is like the next term in the formula. So you do like a plus 1 on all the n's. And it's going to involve a lot of canceling out to look at your answers. So let's do some examples. I think that'll help. So let's look at this example right here. N factorial over 3 to the n power. So again, none of our tests that we know so far work for this one. So we're going to use the ratio test. So I'm going to treat it as the limit as n goes to infinity of, so let's write this down. A sub n is n factorial over 3 to the n. So that's what that pattern is. So a sub n plus 1 would be n plus 1 factorial over 3 to the n plus 1 power. All right. So one thing when we're writing these factorials out, I'm going to rewrite those. So we have to do n plus 1 here. So n plus 1 factorial is like n plus 1 times n times n minus 1 all the way down to 1, right? And then 3 to the n plus 1 is, I'm going to say 3 to the n plus 1. And then we're going to go times the reciprocal of this one instead. So I'm going to put 3 to the n on top over n factorial, which is going to be n times n minus 1 dot 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 down to 1. All right, so let's play the cancel game. So if you remember with factorials, this n all the way down to 1 cancels out with this n all the way down to 1. So we're just left with this n plus 1. Now, 3 to the n over 3 to the n plus 1. This is like I have n number of 3's here and n plus 1 number of 3's. So basically, n of them are going to cancel out. So this is going to go to 1. And after I will reduce all this, I'm just left with 1, 3 left over because there's just an extra down here. So cleaning all that up, I have n plus 1 over 3. And n plus 1 over 3 as the limit as n approaches infinity would be, the absolute value would be 2 over 3, which is going to be less than 0. So this is going to converge. Yeah. No, it doesn't converge. This is not 2 plus 1. Oops. You're adding infinity. Why was I thinking 2? So infinity to this, and this is just going to be the equivalent of infinity over 3, which goes to infinity, which is going to diverge. I won't edit that. Let's try another one. Okay, this looks gross as well. So ratio test. Limit. Let me write this. So this is my a sub n. I don't want to rewrite this. Well, a sub n plus 1 is going to look like this. It's going to be 3 to the n plus 2 now over 4 to the n plus 1 over, and then n plus 1 squared. All right, so the limit as n goes to infinity of the absolute value of a sub n plus 1, so 3 to the n plus 2 power over 4 to the n plus 1 times n plus 1 squared times the reciprocal of a sub n is 4 to the n times n squared over 3 to the n plus 1 power. Now you play the cancel game. So, okay, again with the last problem, this is 4 to the n and 4 to the n plus 1. That's going to go away, and then I'm just left with a 1, 4 left over. Same thing over here, 3 to the n plus 2 and n plus 1. I have an extra 3 up here, and that just goes away. These n's can't cancel out like that. We kill kittens if we try to cancel out right in there. So let's just write this out. I have 3n squared over 4 times n plus 1 squared. All right. So let's L'Hopital's rule this. If you know the kind of pattern here, I can FOIL this out for you. A lot of you might be able to recognize what the answer is right now, but let's just FOIL out the n plus 1 squared. That's equivalent of saying 3n squared over 4 times n squared plus 2n plus 1. So what's going to happen if I distribute that? I'm just going to write the work here. 3n squared over 4n squared plus 8n plus 1. Again, the limit as you go to infinity, and L'Hopital's rule, or just look at the highest degree polynomial. They're both n squared, so we're just looking at the coefficient, and that's going to be 3/4. Now, 3/4 is a number, and that is between -1 and 1, so this guy converges by the ratio test, because 3/4 is less than 1. All right, moving on with my life. So the neat thing, this is a weird one too. Now you got this -1 to the n power. So we can still do the ratio test. Remember with the ratio test that it's absolute value, so you can pretty much just ignore these. But the -1 alternating part is not going to matter. But let's just write out n plus 1 would be -1 to the n plus 1 power over square root of n plus 1 over n minus 1 plus 1 would be just n. So let's do this. The limit as n goes to infinity is going to be absolute value. I'll just write it in there, but we'll cancel it out later. Over n plus 1 over n times n minus 1 over -1 to the n times square root of n. All right, so what cancels out in this case? Well, again, these negatives, they're just absolute value. It's just they're irrelevant to this problem. And does anything else cancel out? No, I can't do those n's because that kills kittens, because it's like that. So writing this out as is, it's going to be square root of n plus 1 times n minus 1 all over n times square root of n. Again, you're taking a limit as n goes to infinity. Now, on the bottom, this is sometimes tricky to see. We gotta think about, like, what is our highest power here? And in this case, on the bottom, I basically have n to the 3/2 power, because that's an n times the square root of n. And on the top, I have like n plus 1 to the 3/2 power. So you're really looking at this. Oh. If you put in n right here, since they're the same kind of power as you're going to infinity, this is going to actually converge to 1. So by the ratio test, this is inconclusive. So we have to use a different test, and we could have gone back in time and said, hey, wait, it's an alternate series. So sometimes the ratio test is inconclusive, and you want to do alternating series tests and say, hey, since it alternates, let's just take the limit as n goes to infinity of square root of n over n minus 1, which is the equivalent. It's like looking at n to the 1/2 power over, like, and then this is just n to the 1 power, so one of the halves would cancel out. So it's like 1 over n to the 1/2 power, and as you go to infinity, that's the same thing as 1 over infinity, which is 0. So does it converge? Yes, by the alternating series test. All right, so we're done with this. So how can you tell which one to use? So here's kind of an order. You always want to check the nth term first and see if it approaches 0. If it doesn't, it diverges. And if it's something very simple, like a geometric p-series or alternating series, just use that test. So look for those first. Like, don't do what I just did in that last problem. And if it's a polynomial, but it's kind of weird looking, use those comparison tests. And if it's factorials and exponentials, use the ratio test. So there you go. We're done. There's my mouse.